In previous videos we've looked at matrix addition, matrix multiplication and scaling a matrix by some number k. Okay, it's also possible to divide matrices in a certain fashion, although not directly. You have to do it indirectly using the inverse of a matrix. Okay, so in prior videos we've shown that our linear transformations can be written in matrix form like this, where you have some new image point, some transformed point x dash y dash, which is a transformation matrix M times your original point or vector in space x, y. Okay. Before we explore how you go about dividing a matrix, I just want to remind you that in general matrices are non-commutative. So in general, A times B is not the same as B times A. Okay, sometimes it can be the case, but in general it's not the case. So you have to be careful when you're multiplying matrices, you know, which side you're multiplying first. Okay, that matters. Okay, if we take our matrix notation here, we can summarize okay, this matrix equation in even more compact manner. Okay, if we call this vector R, okay, R dash, I should say. So R dash. We're just giving this vector, this matrix, a name, R dash. Okay, we're saying that it's some matrix M times the original R. Okay, that's just a way of writing the matrix equation in more compact form. Let's suppose that we want R instead of we want this equation written in terms of R dash, not in terms of R. We want it the opposite way around. So we want some expression where R equals something. Okay, the way to do this normally would be to divide both sides by M, and then they cancel. That would be if this was normal algebra, but in this case we're dealing with matrices, so obviously you can't just do that. It's not that simple. Okay, so what we have is R dash equals M times R. Okay, but what we can do is we can multiply on the left hand side here and here by M inverse. So M inverse, we discovered the last time, is given by this expression here. Okay, if we do that, let's see what happens if we multiply both sides by M inverse. Okay. Now we have M inverse times M. That gives us the identity matrix times R. Okay, just be careful because this is a dash, not a 1 or anything significant like that. Okay, the identity times R is just R, and we can move this over to the other side, so we get R equals M inverse times R dash. Okay, which is exactly the same equation as if we turn it back into matrix form. It's exactly the same equation as we got the last time. So R, remember, is x, y, equals M inverse is now this. Okay, times x dash y dash. Excellent, so this is the equation we discovered the last time. So you can think about matrix division in terms of multiplying by the inverse relevant to your equation, the inverse transformation matrix in this case. Okay, but you must be careful to multiply it on the correct side. If you multiply it instead M inverse on this side, it would be operating on R and not on M. Okay, so you've got to be careful about how this is done.